Hello everyone, my name is Sridhar. I'm working as assistant professor in Mlritm College, Dundigal. Today I'm going to explain antennas and microwave engineering. The what are the outlines of this our subject is the first one is course objective, course outcomes and introduction, antenna parameters and what are the microwave microwave tubes. Okay. Now I want to explain the what are the our course objectives of our antennas and microwave engineering subject. First one is the student able to understand the basic concepts of antenna. The second one, analyze the characteristics of the VHF, UHF and microwave frequency. Okay, and that means the antenna types are depending upon the microwave frequency, that is VHF, UHF and microwave frequencies. Then next one is analyze the characteristics of the antennas. The second one is, third one is, and microwave tubes, different types of tubes and its polarization. What are the signal polarization is there in the microwave tubes, that is discussed in this. The fourth course outcomes. And the fifth one is that what are the solid state devices that amplify the signals. Amplify the signals, that means microwave signals in the microwave tubes. Now we are discussing about the course outcomes. The course outcomes is actually it is depends upon the modules of the course structure. We are having the 5 modules in the antennas and microwave engineering. So we are having the 5 course outcomes. So it is first one is the mechanism of antennas. Mechanism of antennas and how it is constructed and what basis it is constructed and what is the parameters to construct the antennas. The second one is the to establish folded dipole antenna and parasitic elements and dipole with the parasitic elements and the Yagi-Uda antenna. Third course outcome is it is parabolic reflectors, and it is about the parabolic reflectors and arrays of the antennas. The fourth one is the cavity clystons, 2 cavity clystons and O tubes and magnetrons. These are the about the fourth course outcomes. And fifth course outcomes is it is about the solid state devices which are effective in the amplifying the signals. These are the outcomes of the antenna microwave engineering. Let us go to the introduction of our antennas and microwave engineering. Okay, ma. Next, the radiation mechanism of, first of all, what is antennas? How it's radiation? Antennas are the metallic substrates that is produces the radiation. How it is radiation means it is the due to the flow of electrical charges, it will radiate the radiation. That means the reason of radiation is the flow of electrical charges. Okay, how it will be radiated means, for suppose if any long and infinity antenna is there, long and infinity radiator is there, in that one there is no motion. That means there is no motion of momentum of the electrons. At that time also we can't generate the radiation. If for suppose if an infinite distance of radiation is there, there is no electrical charges in that one. Here also we cannot get the radiation. The unless until only if the radiator is curved, bended, truncated, in these shapes only it will get the radiation. Okay, so first we are going for the radiation mechanism of the two-wire antenna. Singular, there are 3 types of antennas are there. One is one wire, 2 wire. The third one is dipole. Okay, now I am explaining the radiation mechanism of the 2 wire. The first one is, the first thing is that in this radiation mechanism we are having the one source. Okay, one source and 2 transmission lines, and at the end there is a open radiator is there. So when the source is given, so here we are taking the only AC signal, not DC signal, because here I want sinusoidal signal towards this transmission line, so that I will get positive side and negative side of this sinusoidal signal. And whenever the sinusoidal signals are, the frequency is very high, that means it will nearer to the these whatever these field lines are there in between these two lines, that will be nearer. Whenever the signal is so long, these whatever the field lines are there, force of field lines are there, that is somewhat distance. Okay, so then what happens, whenever the sinusoidal signal is moving along this transmission lines, these field lines, whatever the field lines are there, this force of field lines will be hit to this signal, and whatever the free electrons or holes will be there, positive charges, then it will hit to that positive charges or negative charges, so it will be jump from one place. So one place to another place. At the end of these radiators, whatever the open side radiators are there, these electrons will be jump from one place to another place, and whatever these field lines are generated in between transmissions lines, these will come towards the end, and these will be detached from this end of these radiators. If for suppose this radiation is, for suppose this radiation is having the EM waves, this radium waves is EM waves. So for suppose its polarization is like this, once clockwise or anti-clockwise, when it is detaching at the radiations at the end of this radiators, this polarization is like this. That means that is circular and closed loop, and it is having the E and M waves. That means this radiation is having the electromagnetic waves at the end. The next one, this is about the mechanism. That means we are giving the source to the transmission lines, and through the transmission lines some field of lines will be developed. These field of lines will be detached at the end of the radiators, and what we call it is as a electromagnetic waves. Okay, the second one is next one is the next course outcomes. In that one we are mentioned the dipole or Yagi-Uda antenna. The basic concept behind the Yagi-Uda antenna is the dipole with the parasitic element. Here we are having the dipole. We are having the dipole, one parasitic element, one dipole and one parasitic element. Dipole with the parasitic element. Now just we discussed about the what is the mechanism of radiation here. The radiation is generated in between the transmission lines, and it is detached from the radiated at the end side. Now the whatever the dipole, this one is called as the dipole. Whatever this one is having the transmission lines. Okay, when the source is applied to this whatever the field lines will be there, it is continued at the end of these two radiators. These lines are detached from this dipole, and this whatever the what we are called it as a EM waves. So these EM waves will incident on this parasitic element, which is not having the source supply, only it is placed in front of the dipole. That means it is not having any source. Okay, when these EM waves incident on this dipole parasitic element from the dipole, these parasitic elements will excited due to the incidenting electromagnetic waves. Whenever this electromagnetic waves will incident on the parasitic element, this will excited due to the induced current. This induced current developed due to the whenever the radio signal is incidenting on the parasitic element, which is not having any source, only it is a single rod, like a single antenna. So whenever this EM waves incident on the radiator or a parasitic element, it will be excited due to the incidenting electromagnetic waves to this parasitic element, and some induced current will be developed due to the induced current. Again this parasitic element, which is not having source, again it will be also starting the radiation due to the induced current in it. So by the dipole and by the parasitic element, we are getting the more gain. That means more radiation or more gain through the giving only to one element, not two elements. Only we are giving one element, we are getting two elements radiation, that is we are getting the more gain. The next one is the based on this concept, we are having dipole with parasitic element, we are having the Yagi-Uda antenna. Yagi-Uda antenna means you know the Yagi-Uda antenna like this. This is the shape of Yagi-Uda antenna. This is dipole, or we can say it as a director. This is reflector, and this is driven elements or parasitic elements. Okay, driven element or parasitic elements. So as we said, in the dipole with parasitic element, we are giving the source to the director element. This is one directing element, this is reflector, and this is driven element or parasitic element. We are giving to this one. Okay, that's whatever the source is given to this director element, so that it will excited and it is giving the radiation. Whatever the radiation it is delivered by the director, it will be incident on the all these parasitic element. Whatever the front side elements are there, that are called as the driven element, and whatever the back side one element is there, that is called as the reflector. Whenever this main radiator, that is nothing but the director or dipole element, which is excited by the giving the source. Okay, whenever the source is given, these are radiating whatever this radiator is radiates some radiation, so that the whatever the radiation is there, that will be incident on the all other parasitic elements. Again these parasitic elements will get some induced current. Again, after getting the induced current, there will be a flow of electrical charges in that radiators. Again, these radiators are restarting the radiation throughout the around this parasitic element. That means by giving source to one, we are getting more gain. Through the parasitic element. That means using one source, we are getting more gain through this parasitic element, through this arrangement. We can call it as a Yagi-Uda antenna, and this is the what are the behind topic is that what are the behind the situation is there, that is a dipole with parasitic element. That means the concept of dipole with the parasitic element, that is implemented on this Yagi-Uda antenna. The next one is the radiation lobes. How the radiation is, for suppose we are having some three-dimensional, that means one antenna placed in this three-dimensional, and centrally it is placed. Okay, or we can say it as a spherical coordinate system. One radiator is placed in a spherical coordinate system, so that any antenna or any small radiator, any small element will deliver in the all directions. But when the maximum radiation is towards some direction, when one antenna is radiating maximum radiation towards per particular direction, per suppose it is z direction, it is x, y. So here the maximum radiation is transmitting towards the z direction. Okay, so that means here it is represented with the major lobe, and these are the called as the small lobes, that is side lobe, this is back lobe, this is side lobe. So wherever the major radiation is concentrated is nothing but the major lobe, or these are all called the side lobes. That means the total radiation, the maximum or 90% or 99% or 90% of the radiation is propagating towards the z direction. That's why it is looking like this. This is a major lobe. That means the total radiation, the maximum radiation is towards the z direction, and the small radiation is like a, we can say it is as a loss, okay, back lobe and side lobes. Okay, this is about how the radiation is concentrated towards the desired direction of an antenna. Next one, here we can say, see, main lobe, back lobe, these are the side lobes. Here main lobe means maximum radiation towards the desired direction. The minimum radiation, these are, we can call it as a loss of this radiation, because we are always calculate the radiation towards the desired direction. Okay, the radiation towards the desired direction, then only the receiver side we will take only the desired direction radiation, not to back lobe, side lobe. These are the neglected. Next, the best example of the dipole with the parasitic element. The another antenna is there, that is dipole with the, or suppose it is a folded dipole antenna which is based on dipole with the parasitic element concept. For suppose here we are having two radiators. This is one and this is two radiators. Okay. So here at the center we are giving the sinusoidal signal. Okay. Here current I is entering into this two. Here one and two are folded, like it's a folded, and so that here the current is given at the input side. This current is deviated I1 and I2. At this end there will be a ground, that's why it is current is deviated. So in this one antenna there is a I2, and that means I by 2 current, and second antenna I by 2 current. Okay, the two currents are flowing into the these two radiators. What happens? The first one is generating the self impedance, that is Z11. Second one also generating the self impedance, that is Z22. This is 1, this is 2, that's why it is Z11, it is indicated by the Z22. The second, due to impedance, mutual impedance, so whatever the radiation is generated by this first one, it will be incident on the second one. Whatever the self-generated radiation is there, that will be incident on the second one. When second one also get excited due to the first one, that means the self-impedance of the first radiation incidenting on the second radiator. The second radiator, although it is having the self impedance, that is Z22, but due to the Z11, that will due to the first antenna, it will, in the whatever the radiation from the first antenna, it will incident on this, the second one, and whatever the radiation generated by second one is there, that means the impedance Z22, that is incidenting on the first antenna. That means due to the first antenna, second will be affected. Due to the second antenna, first will be affected. As I say, dipole with the parasitic element. The first antenna, if it will radiate, the second antenna will also affect. That means incident on that some induced current will be developed, and again radiation will be also developed. At the same time, here first one, second having its mutual impedances, mutual radiation capacity. Again due to this one, it is also getting some induced current, and it is also generating. Due to this one, this is also getting some induced current, and it is also starting the radiation. That means self-impedance and mutual impedance. Here self-impedance is Z11, mutual impedance means due to the second one, it is Z12. It is self-impedance in the second one is Z22. Due to the first one is, it is Z21. Z11, Z22 are the self-impedances of their own, and Z12, Z21 are the mutual impedance. So get together Z11, Z22, Z12 and Z21. Totally how many are there? Totally 4. 2 are the self-impedances, 2 are the mutual impedances. So at last, the radiation is, when we calculate 4 into 73 ohms. 4 means 2 mutual, 2 self. That means 2 square. See here, we are having Z11 as a self impedance of the first one, Z22 as a self impedance of the second two. Z12 due to the second one, that is for the first one, that is mutual impedance, and Z21 that is due to the first one, it is mutual impedance of second antenna. Total we are getting the 4, and now we can say it as a, if you are taking two dipole antennas and folded together, we can get square of its radiation. If you are using another one, that means 3 radiators, we can get the 3 to the power of square into 73 ohms. That means we can get the radiation rad is equal to the number of elements and its square into 73 ohm. This is about the how the what is the mechanism in the folded dipole antenna, and what is the mechanism in the Yagud antenna, what is the principle of the dipole with the plastic element, and it is about the antennas. And now discussing about the microwave tubes. The microwave tubes, how microwave tubes are the VHF and UHF, and that means very high frequencies and ultra high frequencies, and its antennas. That means Yagud antenna, if you take the paraboloid, these are comes under the VHF and UHF. And beyond the frequencies like UHF, we will use the microwave, that means hollow shaped microwave tubes. So here we are having the reflex crystal and O tubes and O type tubes and M type tubes and magnetron tubes for the microwave generating frequencies. And another is microwave antennas are there. One is, for suppose reflector is there. Reflector we can use it in the normal antennas and microwave antennas. And horn antennas, that means it is having the hollow shaped tube, and in that one the very high frequency, that means more than ultra high frequency signal we can transmit through that's microwave tube. And at the end of the open end, whatever the open end will be there, that is like a horn. Horn means we can say circular in shape, flaring shape, or all that. Okay, when the signal is very low below the UHF, we can use the normal antennas and its parameters, its calculation. And beyond the microwave frequencies means we can use some cavity tubes and cluster tubes. Okay, ma. Thank you.